afternoon, everyone. We are Group 6 and our IoT solution contributes to the agriculture industry. Our IoT solution is to monitor crop health, provide corrective measures for plants and the environment, and also view real-time data in the form of graphs of our sensors, namely the temperature sensor, the humidity sensor, and the soil moisture sensor. Next slide. So meet the team. I am Dara, and Ethan Barnes is our group leader. Des Jr., Sharon, Liam, and Steve. Next slide. The agenda for our presentation today is we'll start off with the overview of our IoT solution. We'll then go into the IoT demonstration, which will also show the graphs and the dashboards. And then we'll be discussing the benefits of our IoT solution, the challenges, the potential impact, as well as the future recommendation. I'll now be passing over to Ethan Barnes.
Okay, hello everyone. So for our IoT device, we took in a new way at farming, a new revolutionary way. So our IoT device is mainly based on our Raspberry Pi, machine learning algorithms, and various sensors as seen as demonstrated. So for our backend, we used Firebase, and we managed to create a web app with HTML, JavaScript, and various libraries that we imported to properly display our ideal model for our IoT device. I will now be handing over to Junior, where we will go through our live IoT demonstration.
Is everything set up?
Yes, sir.
Okay, so I think we can come once again and have a look
so
at. Or not yet.
They
Okay.
They can, sir.
Okay.
They can.
Okay. Okay.
Okay, so as you guys can see, we're making use of graphs to basically represent our live data. So the data is fetched from our Firebase database, and the data basically is capturing the data from our sensors, the temperature, the humidity, and the soil moistures as well, right? Along with their respective timestamps. And now, in order for us to be able to display those graphs, we made use of libraries from Plotly, right? And how they basically work is that the sensors capture and read the data, and they store it into our Firebase database, and then our web application then goes on to fetch the data and plots it onto our graphs. And now I will forward it to Ethan. He'll do the live demonstration of our live detection.
I would just like to add on to the graphs. We would love to show a live representation of our graph, but due to time constraint, it only updates every 1 minute and 20 seconds. So if you guys want to stay for 1 minute and 20 seconds,
I will do.
we can do that. But I will move on to our detection. Okay. So now we will use our Pi camera. So
Can we get everyone to
maybe
just come
everyone
around?
can Maybe come closer to our IoT device so we can demonstrate. So, as you can see, we ran our script to capture. We're using the Raspberry Pi to capture a live image of our crop. Once it is then captured, it is stored onto the user's desktop, which we can use to upload to our disease detection model. So now I will ask Junior to upload our image. We can select the image from our desktop. Desktop. Yeah, as you can see, there's the word from Steve. And we can open it.
Stephen, you are a new plant.
Let's just hope it doesn't interfere with the model. And we can then click the button that checks, and it will detect the disease, powdery mildew, and the confidence level. So if we run another image, for instance, a aphids image, unfortunately I couldn't get physical aphids to display on the plant. So if the image detects an aphid image that says go with OIP5, and we run it through there, We get the disease efforts with the confidence level and the treatment. We can now move on to our live detection. So this is where we make use of our webcam that will physically represent live footage to the user, and will be able to identify what disease it currently has. So start webcam. As you can see, we can now see the physical image right over here. And as you can see, slugs and powdery mildew are the highest because that is evident. As you can see, the holes that's created here represent slugs that are snails that are eating on it. So there we can see a live demonstration of which disease is in our plant. We can then move on to a treatment, which is a database table. You scroll up. That lists all the physical diseases that can be found in different plants, spinach plants. This provides ease of use for the user so they can easily identify what disease they have and what treatment should be done. This is the bulk of our IoT device, is to provide live demonstration of what diseases are prominent in your farm, and then what are the corrective measures that should be taken, as stated, treatment and so forth. And that concludes our live demonstration.
Great.
I will now call on you, Sharon, that will be doing our best.
In introducing our innovative IoT solution for monitoring of plant health, we emphasize the potential benefits, particularly in optimizing resource efficiency in agriculture. By utilizing machine learning and IoT technologies, our system enables data-driven insights that promotes the efficient use of water, nutrients, and energy, resulting to reduced wastage, resource wastage, and lower cost for farmers or any user. The solution capacity for data-driven decisions stands out, offering the tools to optimize planting schedules to allocate resource effectively and enhance distribution planning. Beyond financial gains, our IoT technology enhances crop output and offering real-time monitoring and disease detection capabilities. Furthermore, the other benefit is the supply chain stability, which offers healthy crop results in more stable and reliable supply chain, reducing disruptions due to disease or unhealthy plants. Overall, it serves as a vigilant partner of the fields, providing instant alerts and recommendations. This capability empowers farmers to take immediate corrective actions, powering potential health issues from escalating. Thank you.
We'll now be moving on to Liam, that will be presenting the challenges we face.
So when we started this project, it was important to understand the technical complexity of it and the initial investment. So the complexity just involved all our knowledge on it, how much we needed to learn in order to integrate the model together. And then our initial investment was basically just the cost of setting up and what we needed to acquire to finish our model with. So we decided to build a web application on Flutterflow, but we ran into a problem with it fetching the data from the database. We decided to then pivot to a web-based application. We ran into a similar problem with regards to fetching the data. To solve this problem, we had to basically stop coding. We thought that it was important to go back and learn everything about the Firebase website, Stack Overflow, and GitHub. Those resources eventually helped us to overcome that problem. Once we were able to fetch the data from the database, it was important that we represented on a graph, which we ran into a problem with as well. The problem stemmed from a data array problem. To solve this, we made the code clear the array, fetch the data again, and then run through it once. With regard to setting up our actual model, we also ran into a problem with the camera itself. So the Pi camera, we struggled to make it work on OpenCV. So instead we opted for another use case, which was to use our webcam to do the live detection of diseases. Another challenge we faced was with soil moisture itself. We didn't have the entire soil moisture part, instead we had to go fetch it. The part that we were missing was the analog to digital sensor. And yeah, sorry, that was all our challenges that we had. I'm showing the hand over to Stephen.
So as previously alluded to, our solutions use advanced cameras and machine learning to detect fungal diseases in plants as well as climatic conditions in plants and suggest measures to correct them, thereby ensuring a healthier agricultural supply chain. So our project contributes immensely to supply chain reliability by ensuring a high quality supply of agricultural produce. It also fosters economic growth by bringing about overall productivity and efficiency in the agricultural sector, which is obviously in South Africa, it's a major thing, agriculture, as well as, it's given a backdrop of food insecurity in South Africa and Africa, and I suspect globally as well. Our solution can bring about food security and thereby improve lives and livelihoods. Our solution can be applied and several industries can benefit from our solution, including agricultural, as mentioned, education, supply chain, as well as home gardening services. So I'll now be passing on to Tina for future recommendations.
So I'll be talking about the future recommendations of our IoT solution. So our IoT solution can advance by integrating advanced machine learning algorithms to enhance disease detection precision. Expanding the range of monitored we look to expand the range of monitored parameters such as atmospheric pressure and sunlight exposure, which would provide a more comprehensive view of the crop environment. So we also look to ensure scalability and accessibility through a mobile application, as well as send out SMS notifications, which can empower farmers with quick responses to emerging issues, which would then provide remote access, mobility, and scalability.
Be providing a mobile app that offers mobility and also access offline access and integration to any other into the supply chain even further. So this is just the process. This is how our mobile app will look like, with the homepage showing the temperature, soil moisture, and the detection of the plant health. Also